My name is Leah Schick. I'm from the Alexandra Institute, and this is the fourth in a row of webinars around data spaces with the purpose of informing people in Denmark primarily, but of course everyone can join in, especially this webinar, and the last one has been solely in English, so that also means we can open up more internationally. But the main purpose of these webinars is to inform both the public sector and companies in Denmark who are interested in this new data economy, data sharing economy that EU is pushing right now, together with a lot of big organizations and companies, of which we will meet quite a few today. So this one is about I need to get over here. Technical building blocks, and as you see here, we have had our first webinar with the more general introduction. Each webinar I host together with other organizations who are more specialized in the specific theme of the webinar. So the first one was on standardization and data spaces, and that was hosted together with the Danish Standardization Agency. The second one was around energy data spaces, and this is because both that I'm working within energy, and I work a lot with the Danish energy sector on data spaces these days. And also the row of webinars are funded by the Danish cluster, Energy Cluster Denmark. So we had one webinar specifically on energy data spaces. And then the last one was on governance and legal. The legal frameworks around data spaces, and this one is around the technical components for data spaces. The three earlier ones, you can all see the recordings on the web page that you have below in this slide. Of course, you'll get the slides afterwards. And you'll also get the link for the recording. And this also tells you that we're recording this webinar. So of course, I need to inform you about that. Alongside the webinars, we are hosting two so-called expert panels where we have gathered around 20 people from the energy sector, from TSO, DSO. We'll meet the TSO today also, together with different people working with integration in the energy sector, with heat pumps, with making the different technological components for the energy sector. And they have met the first time, and they're meeting the next time next week. And then the fifth webinar, it will be we will present some recommendations from this expert panel. So this is kind of the big picture. But today we are hosting both this webinar and also the expert panel together with KMD. That's Mads that we have here. He's today sitting on his keyboard ready. So yeah, and you're presenting what you in KMD is doing together with your colleague from NEC, but we'll hear more about that later. So the agenda is I'll first do a very short introduction, much shorter this time than the other times, because I want to make more space both for our presenters, but I also want to make more space for questions today. So I really hope that we'll have time to have you people engage in the discussion. And you can, of course, always raise your digital hand. You can write messages in the chat. I'll try to look at them all the way through. But also, it's really nice if you want to put on your camera and your mic and post a question yourself. It often makes it more engaging. So our first speaker is Peter Cohen, who is working on the Eclipse data space components. He's from Microsoft and a very active member of the IDSA working group, architecture working group. So you'll present us with what you're doing at IDSA and how the whole Eclipse project is actually bringing together a lot of the technological development being done in data spaces right now. Then Mads from KMD and Arno Kovac from NEC will present how so KMD is owned by NEC, and therefore you have a shared, of course, engagement with data spaces, and you will be telling about your experiences with working with the Fireware context broker. And that said, Fireware is also a very big contributor to the technical components to data spaces. Then we'll have Jens Svee from Energinet, who will talk about how Energinet is working with data spaces. And we have Sebastian Kleff, who's the CEO of Sovety, which is a company that has sprung out of Fraunhofer, working with the IDS data space connector. So you'll be telling us about this. So a very interesting program. But first, a few slides here. So the overall vision we are talking about is, of course, the whole EU digitization strategy, where the main purpose is to create this one single market, an easier way to exchange data, where data are not stored away in many different fragmented companies and organizations, and they're not locked in bigger monopolies of data owners. So the whole vision is to actually make data flow more freely. I've presented this figure several times, so I'll just say today we're talking about the bottom layer. This is the different infrastructure components, all the stuff we need to actually do the implementation. So for those of you who haven't joined the previous webinars, I just want to say there's some different, you might feel like you're lacking a lot of introduction. We will skip that, but you can find it in the webinar, but also in this Danish introduction to data spaces, which I've been making for and with the Energinet. So I just want to say it's all in there. So don't freak out if you think, what are they actually talking about? Afterwards, just go in and see this. But if we should make the very short introduction, data spaces is defined as a decentralized infrastructure. So it's a decentralization that is important for trustworthy data sharing. So how can we actually trust data when we exchange it in a decentralized way? Of course, the centralized data exchange makes it easier to actually know what data is it, where does it come from, but what happens when we start to actually exchange it decentralized? How can we actually hold on to the trustworthy data sharing there? And then the most important part is that it's an ecosystem based on commonly agreed principles. So decentralized systems, but that works only because we do agree to the same principles for exchanging data. And that's both within one data space and it's across data spaces as such. A lot of this agenda is driven now. It has for a long time been driven by organizations like IDSA, International Data Space Association, and others. But EU has now really caught up on it and is using a lot of this in for the making of new legislations. Like the Data Act that is coming now. I've just picked the two big ones you see in the middle is the ones that I find is most important for the technical components, because the Data Act is actually saying that we need to make more data available for the ones who produce the data. So it's not only the ones who own the product or who has made the product that actually should have access to the data, but the ones who buy the product and therefore produces the data also need to have access to the data. And then we have the Interoperable Europe Act, which is coming up, or has been proposed but not decided upon, but I will not go into it. I know that Peter will talk about the different layers of interoperability presented in this act. And then I also want to make a small recommendation or a commercial for a webinar tomorrow from 3 to 4. Danish Standardization Agency is making a webinar about new EU rules for the use of data around the Data Act. So data spaces is it's slowly, the whole framework is slowly being, or not slowly, quickly and slowly at the same time being developed. And the latest version from the Data Space Support Center of what the data space should be made up of is these different building blocks, where we have the building blocks around the organization and business building blocks. We've talked about that last time. And then we have the more technical building blocks. The technical building blocks can be divided into 3 parts, or they are divided into 3 parts. And there's a link on the bottom here. This is from the Data Space Support Center's blueprint 0.5, which was released just a couple of weeks ago. But you have these 3 pillars. The first one is around data interoperability. So this is about the need for semantic models, data formats, interfaces, APIs that actually can speak together. So we make sure that we can exchange data between different people, even though they are using different systems, different technologies and everything. But we actually have the link, the way that we can understand and exchange data across different actors. An important part of this is also the provenance and traceability, because that's a very important part of trust and also of being able to make an actual data economy, is that we can trace who has had access to which data has been exchanged in which ways. The second pillar is the sovereignty and trust. So it's about the different it's about making sure that the ones who has data and says, I am this and this person or organization, identity, that it's actually the one that they say they are. So this is a big issue for data exchange. How can I make sure that the ones who says, here is some data, is actually the actual legal entity that they say they are? But also, so this is identity management, but also the access policies. What are you allowed to use my data for how long, for which purposes, which part of the data? And this is a very important part of the whole trust element. How can we make trustworthy data sharing? And the third pillar about data value creation is very much around the whole, how can we make a marketplace for data? In order to make a marketplace for data, we need to be able to find it. We need to be able to buy it, or to actually also understand what kind of products is it that we can find in a data marketplace. So when you search for data, how can you actually find out what kind of data it is? A data set is not worth a lot if you don't understand what is in the data set. Yeah, so this is a very short introduction. Here's some further readings. This is just some of it. There's a lot out there, but just exactly because there's a lot, it might make sense sometimes to just have a few to look into. So these are the words from me today, and then I will hand the word to the screen to Peter, and I look very much forward to hearing your presentation. So you're based, as we see on your screen, you say the weather's not that nice, but you're based in Vienna. Like Denmark, you also have rain.
Thank you, Leah. Yeah, that's the beauty of virtual meetings. You can cheat a little bit if it's raining outside and just put up a nicer background. So yeah, hi, I'm Peter. I'm based in Vienna. I work for Microsoft in a corporate group that's called the Corporate Standards Group. We are part of the Corporate External and Legal Affairs team. So basically, this team works on standards that are across multiple Microsoft products. So in this case, for data spaces, I care about an ISO standard development for data spaces, about CEN/CENELEC harmonized European norms, about the development of a standardized interoperable data space protocol for communications and contract negotiations in data spaces. And I also take care of the participation in open source development for data spaces. So Microsoft is a contributor to the Eclipse Data Space Components project and is one of the founding members of the Eclipse Data Space Working Group, which will go live in the next couple of days or weeks. So you will soon see PR about the founding of this new working group within the Eclipse Foundation to orchestrate and coordinate between multiple open source projects that together implement components and standards in the data space ecosystem. And in my role, I'm working collaboratively with a lot of organizations in this area. So with Gaia X, with IDSA, iShare, Citra, MyData, BDVA, you name them. It's a large ecosystem, a big family of organizations that are interested in trusted data sharing. And in particular, because they are developing the concepts of data spaces and the business and functional requirements of data spaces, I'm in IDSA, the International Data Spaces Association, a co-chair for the Rulebook Working Group and for the Architecture Working Group. And without further ado, let's have a look at how we see data spaces. So as Leah already said, there's a lot of, let's say, political and legislative and regulatory pressure to develop data spaces. There's the EU data strategy, the EU Data Act, especially with Article 28 defining interoperability of data spaces through harmonized standards, and Article 30 that specifies the use of smart contracts for data sharing and the adoption of data spaces. So basically, the big elephant in the room always is, why is Microsoft doing this if this is all just European law? We are not building data spaces as a service on Azure. We are not building specific protocols in Azure. But what we see is the value proposition that data is providing value only when it interacts. Data needs to travel to create value. If you have data locked up in your basement, then that data does not do anything of value. It's just sitting there and costing you money while you are paying for the infrastructure to host the data. So if you want to generate value from data, you need to allow this data to travel. But for that, you have to have trust that the data is being used in the right way for the right purpose and only shared with the right people. And over the last 20 years, I think everybody has seen plenty of news articles and has read plenty of white papers that tell you how dangerous it is if data gets into the wrong hands, data that has been misused for fake news, for AI engines where you don't want your data to end up with. And so we are at a point where we need to say, hey, we need to find a way, how do we create trust in the sharing of data so that I, as a data holder, can be sure the data is not going to be misused by the other side, or that I can develop a certain risk estimate of how likely is it that my data will be used in a way that I don't agree with. And the second thing is also, there is a certain angst here that we've all heard how valuable data is. Data is the new oil, data is what makes the economy run. And I have this great valuable data in my basement and I have no idea how I will create value from it. So we need to create a system that will ensure that if I hand out my data or share it with others, that I will participate in this economic value for the data that I have shared, because there's a lot of fear that other companies will monetize on my data if I share it. And so people are locking up their data and are not sharing it. And if data is not moving, then we cannot build an innovative data economy. We lose out on a lot of value that the data provides. And yes, this is something that has been first recognized in the European Union with the EU data strategy. However, it is now more or less a global phenomenon. We see very similar discussions in Japan. You see discussions at the level of OECD or on the level of G20. We see similar discussions happening in Australia, in Brazil, in South Korea. So basically, this is starting to be a global phenomenon. And another thing that is driving data spaces is also we see a lot of challenges coming towards us that will not be solvable if we cannot share data. So we see things like global sustainability laws. We see laws like in Germany, the Ethics in Supply Chain Act, which essentially forces companies to share data about their supply chain, about their production methods, all the way from the first screw to the final product that is handed over to the consumer. And this legal regulation will not be possible to implement if we do not find a way how to share data in a trusted way. So the way that we look at this from the perspective of the IDSA working groups is that basically everybody will have to participate in multiple communities where data needs to be shared. So there is let's say, a private community, all suppliers of company XYZ. There might be an industry group, all producers of thingies and widgets in healthcare in Denmark. There might be another community that is based on jurisdiction, like the German supply chain law applying to all German companies larger than 3,000 employees. So everybody will be part of one or probably many such communities. But all those data economy communities will have different requirements on how can data be shared in those communities, what is required to trust each other in those communities. Some might be centered around, hey, let's find the cheapest way to fulfill the regulation. Some might be centered around, hey, let's find a way how we get more money for our data. So very different motivations in different communities. And I think that data spaces are a great tool to manage all those different communities. So the way we see data spaces, and I will explain this slide in the following slides in a more graphical way, because here I understand it's just a wall of text, so bear with me, we will get there. But a very important part for us is that data spaces are inherently decentralized infrastructure with autonomous players that can act with autonomy and with agency over their data. So basically the thing that is very often summarized as digital sovereignty. So you as a company or you as an actor in a data space have the necessary means to decide when are you sharing what data, under what condition, with which other party, and what are the rules for that data sharing. And the way we do this is basically a data space has only one central element. This central element is not even a central infrastructure. Think of it more like a common element than a central element. That's the data space authority. The data space authority provides the rules under which data can be shared in the data space. Data always stays where it is at source, so with the data holder that participates in the data space. Only once we have agreed through policies how we want to share the data with whom, data can travel, and always only peer-to-peer between two participants. It does not need to travel through any intermediary platforms that would aggregate data and mine data that is not theirs to be seen. And so that means participants always negotiate directly with each other data contracts, and those data contracts have the access policies, the contract policies, and usage policies in them for each specific item of data. We will get to that in a second of how that looks like. And last but not least, it is very important that data spaces need to be infrastructure agnostic. You have to be able to participate in a data space, no matter if you are deployed on a hyperscaler cloud, or if you are in an on-premises data center, or if it's an IoT device or an edge device in a factory. Participation in data spaces has to be possible from whatever technology and infrastructure is available and that hosts data. So when we look at the characteristics of data spaces, we're trying to find architectures that maximize the autonomy, or as some call it, the sovereignty of each participant in a data space. And the important thing here is that we say maximizing, because if we say sovereignty is the only thing that we care about, yes, that is technically possible, but sovereignty costs money, because if you want to be fully sovereign, you need to own everything all the way down to the design of the chip that executes your code. Because in theory, any step in the value chain from the silicon mined to the data shared is full with intermediaries. So 100% sovereignty is a bit of an illusionary goal and impossible and also impractical, because nobody would go and dig up silicon in their backyard and figure out how to build a chip and design a chip and then build an operating system and build a cloud system and so on. So at some point, you need to decide where do you lose control? And in data spaces, we have not a clear answer to that. We have a spectrum of areas where you say there are data spaces that will have a lot of centralized control because it is easier to do and it's the right thing for the audience because it's mostly for smaller companies that don't have such a highly sophisticated IT capability that they could run their own data centers. And then there's approaches with highly decentralized data spaces or highly decentralized participants that run their own identity system, their own data catalogs, multiple connectors, and so on, and therefore can take on more responsibility in their sovereignty decisions. And also an important design factor here is, yes, centralization of data space functions make it easier to manage the data space, but it makes it also a bit more dangerous because whenever there is a centralized element, that centralized element will start accumulating value, and at that point will become a target of hacking attacks and will become a point of failure if there should be any mistakes in its operation. And so building data spaces in a decentralized model basically distributes the risks on all participants and therefore also makes it harder to attack the data space in its entirety or to bring down the data space through technical error entirely. So yes, that was now a lot of text on slides. I will be better now. We go now to slides with very little text and mostly pictures. So here's a graphical representation of how we see the design of a data space. A data space is not a physical thing, not a room that you go into and close the door behind you, but it's more of a context envelope where you think, okay, now I'm sharing data in the context of this data space. And that data space basically has two roles in it. One role is the data space authority that manages the rules of this data space and also enforces those rules. So if somebody does not fulfill the rules that are necessary to be part of this trust context, the data space authority will revoke their membership certificate. And therefore, the data space authority also needs to maintain the data space participant registry. So it needs to know who has a membership or a loyalty card of this data space and therefore is a trusted member. And so the data space itself then basically has this data space self-description. So that's data space self-description that says what rules apply to this data space, who is allowed to join. Somebody needs to manage that. So that usually is done through the data space authority or through operations companies that are authorized by the data space authority. So the data space authority could be a legal entity that does not operate any IT infrastructure, but it hires operations company that then together provide the infrastructure services of a data space. And the participant is basically a member of this data space once it fulfills all the criteria to join. Once the membership certificate is issued, the participant includes it in its self-description with some other information, like whether the participant is Gaia X compliant, if the participant operates within a specific jurisdiction or a specific industry, which technical norms the participants support, and so on. So a lot of information that other parties will need to make the decision if they want to trust the participant or not will be included in that participant self-description. And so as I've mentioned before, there is multiple ways of how we can operate the data spaces in terms of the services required to represent the data space authority. The easiest way to do is to say, yep, the centralized authority just operates one central catalog of membership registrations, one central catalog of available services and data endpoints, a central identity server. That is definitely the easiest, but it also gives control to that central operation company, because that operations company basically could decide arbitrarily if it revokes somebody's membership certificate or whether you get listed on the first page or the last page of a catalog. And also it is a certain security risk, because then all you would need to do is hack that centralized data space authority and you have control over all participants in that data space. That's why we usually recommend that data spaces should be implemented as a decentralized network. So every participant themselves hosts their own identity information, hosts their own data catalog, and is responsible for checking the credentials of other participants that they have contact with or where they negotiate data contracts. But that puts a lot of work on the individual participants and is a rather sophisticated way of running your data space connectors. So very often we will see a hybrid model where we say a set of federators or service operators for the data space authority run in multiple instances the services of the data space authority, and participants decide on availability or trust or whatever criteria they have with which federator they cooperate within that data space. But there will be always more than one federator that takes care of handling the identity and the catalogs of the data space. So to put that into a slightly different view of the model, and I'm sorry that this picture is so small, that was designed to be zoomed in the presentation, which doesn't work so well here remotely. Basically, the orange blocks on the side are the participants. Every participant has a connector that connects it to the data space. And the data space here is marked as this green circle. Since it's not a physical thing, it's just a context. In that data space, every participant joins that context through the connector. The connector is the magic gateway where information flows. Within this circle, only metadata is exchanged, never the actual valuable data from your sensors or your production line or the data that you have stored about your customers. Every participant manages their own catalog of available data assets and caches information from other people's catalogs to use them when they negotiate contracts. And they have an identity system which manages identities through decentralized identities. And then anything that happens within that data space, let's say you need a marketplace that enables you to sell and buy your data assets. Such a marketplace would also be just a participant because it needs to have a contract with you that you're willing to share information about your data assets, and it offers a data asset itself, which is the list of prices for the data assets available. Another example of a participant could be a so-called observer or an auditor. So you could have a data contract with one specific participant that then acts as an auditor of regulated transactions, for example, in financial services. And there could be multiple auditors within the same data space because one of them specializes in financial transactions and the other one specializes in monitoring transactions of healthcare data. But the important thing to note here is that within the data space, it's always only participants. Everything is a participant because in the end, when you exchange data, you need to have a trust relationship to exchanging the data. And all roles can be built from those participants. In the data space itself, it's just metadata describing the assets that's being shared through the data space. The actual useful data that is being sold or shared with others is traveling on secure channels directly between the two parties that are sharing data with each other. So let's dig a little bit deeper into the topic of the policies. We have in a data space multiple layer of policies. We have membership policies that define whether you can join a data space or not. Those membership policies usually are defined by the data space authority. So the data space authority will say, hey, this is an energy data space for Denmark. So you need to be registered as a Danish company working on energy. You need to have a valid EIDAS ID. You need to agree to use the following participant as a regulator for energy transactions, and so on and so on. I'm sure there's 100 rules that will make sense to limit the membership in an energy data space. Then once you are in the data space, you have access policies on the data catalogs where you will say who is allowed to see this asset listed in the catalog. So you could say this asset is only visible to suppliers of this specific company. This asset is only visible to regulators. This asset is visible to everybody, even citizens that want to see it. And then once you find a data asset and you negotiate a data contract, you have contract policies that, for example, could say to share this data, you need to first provision a data landing zone in a Danish data center, because I will only share this data with you if you prove to me that the data stays in Denmark. And once that has been executed, the actual asset can travel to the other side, or compute can come to the asset. And then the usage policies are being used. And the usage policies could be something like, you're only allowed to use this data for prompt engineering, but not for training your LLM in the AI engine. Or you're not allowed to use this data for healthcare purposes. You're not allowed to use this data in procurement. This data is only for engineering and research purposes. So there's various usage controls. Some of those usage policies are only executable in the legal domain, but there might also be some usage policies that are executable in the technical domain. Like, this data needs to be deleted after 3 days. Please send me a confirmation to the following web address that the data has been confirmed, deleted after 30 days, who has deleted it, and who has accessed the data in the meantime before it was deleted. That is something that is technically implementable.
Peter,
yeah.
I can see that you have a lot of slides left,
yes,
and we only have around 6 minutes.
We are skipping some because
okay.
You will share the slide deck afterwards.
Yes.
So the processes of how you join a data space, how you negotiate a contract, that's in a lot more detail. It will be in the slides that are downloadable for the session. There's 2 more important topics that I want to go to. One is the question of interoperability, because we already talked about the European interoperability framework. And I think in data spaces, we need to talk about 2 different levels of interoperability. One is the intra-data space interoperability. So can all participants within the data space talk to each other? And the second question that comes up very often is, how do we do inter-data space interoperability? So let's say I have an automotive data space and I have an energy data space, and somehow I want them to interact because I need to provide information on electric charging stations for electric vehicles in the city. So in the case of the intra-data space communication, we are working on standardizing the data space protocol. And the data space protocol is as universal for data spaces as HTTP is for the web. So the way that you can use any browser and any web server, as long as they speak HTTPS, you will be able to exchange data. There is a protocol currently being designed called the Data Space Protocol, which is going through development right now and which will be standardized, and where the Eclipse data space components are the reference implementation of open source of that protocol. So as long as you use that protocol, you are technically interoperable. But when you look at the European interoperability framework, there are other layers on top of it. Like, are you semantically interoperable? So does delete after 7 days really is something that everybody understands in the data space? That is an interoperability that is not guaranteed on the technical protocol, but that is provided by the data space authority. So when joining, you basically say, hey, I agree to the contracts and rules of the data space authority. And that one will also tell you there is a rule that says delete data after 7 days, and this is how the rule has to be interpreted. And that's the semantic interoperability layer. Then there is the layer of organizational interoperability. So how do business processes work within the data space? That is also something that is defined by the data space authority. And last but not least, you have the legal interoperability layer that basically says, do we have legal interoperability in the contract? So if one side puts into the data contract, this data cannot be used for LLMs, does the other side understand what that means? And that, again, is something that is defined through the data space authority. There is a second important interoperability standard, the ISO 19941, which basically does exactly the same. It just splits the technical layer into a transport and syntactical layer and has slightly different names, but otherwise it's exactly the same model as in the European interoperability framework. So how does that solve the problem of interdata space interoperability? Very simple. Technically, it's all the same. If one participant needs to access data in the other data space, it's the same data space protocol. But then it's a question of semantic model, business model, and legal equivalency. And that is being resolved at the level of the data space authority. So if one participant needs data from two data spaces, they need to join both data spaces because they need to accept both legal contracts. They need to be able to execute both business processes. And with that, it's the responsibility of the participant to understand what those two data space authorities have decided as rules for their data spaces in interoperability. And so all of that is currently being defined in various standard works. So we have an ongoing ISO project, the preliminary work item 2151. For data spaces, there's a Senelec workshop on trusted data exchange as a preparation for an upcoming harmonized norm. And within IDSA and Eclipse Foundation, we work on the technical and semantic layers through data space protocol specification, trust protocol specification, and the semantic models for the policies. And then the main reason why I was asked to present here, the open source implementations, they're all reference implementations of those standards and the processes that I just described. So everything that I mentioned here, the policy engine, the catalog, the identity management, those are components of the Eclipse Data Space Components project. The Eclipse Data Space Component project is an open source project within the Eclipse Foundation, started by Fraunhofer ISST with Microsoft, BMW, Amadeus, SAP, ZF, Mercedes as the original contributors and committers on the project. By now we have a lot more than when I took the screenshot. And that project basically tries to do a reference implementation of all those standards. It is not a finished product. So you cannot come to Microsoft and say, hey, give me 7 licenses of EDC, because that's not how it works. EDC is a code framework for our development partners that then take this code framework and use it to enable their products to be compatible with the standards set forth through the data space protocol and through the reference architecture models of IDSA. So for example, we will hear later from Sovety. Sovety is using the Eclipse data space components to build their data space as a service product, and Sebastian can for sure tell you more about this. The important thing here is that it also implements the Gaia X Trust framework, and it is managed under an Apache 2.0 license. So basically it is free to be used in commercial and non-commercial use. And the Eclipse processes basically guarantee that it will be free of intellectual property rights. So when you use the Eclipse data space components or a product built on top of it, you can have the safety that you know that this is really free open source that you can use in your projects. And so one more minute before I hand over to the next one, the big picture basically, and you can look at this in more detail when you get the slides. So we have the governments on the top giving you the regulations. We have projects like the EU DSSC, the support center, that are translating those requirements into requirements that can be understood by organizations like Gaia X, IDSA, iShare, MyData, and so on. And then we have the Eclipse Data Space Working Group that acts as a coordinating umbrella for all the open source projects that are implementing data spaces. And the Eclipse Data Space Components right now is the central project that is the furthest along. The ones in green are new projects that will be started over the next couple of weeks as we go further in the stack and as we make data spaces more complete. But basically this is currently the landscape, the picture. So the layers above the Eclipse Data Space Working Group define the how, And in the Eclipse data space working group, we make sure that there is software that implements the how that is usable for the entire world. And with that, thank you for having me. I always have to show this slide. Please, please, if you're interested in data spaces, join us. The more the merrier. We're nice people. We don't bite. We just love to write good software.
Thank you very much. And there's no questions in the chat, but also we have time in the end for questions because we don't have that much time now. But I think what is important to take away from here is that there's being technical development is being done a lot of different places, but the Eclipse Data Space Foundation is trying to actually gather a lot of the open source development in one place, because I think people have been and still are a bit like, where should we look and what's happening where? But I think the Eclipse is a good way to start to actually look into the code and what's being developed there, and then think about questions in the end, because then we'll have to jump straight to our next speaker, which is Mads from KMD. So I guess you can just take over the screen.
I hope I can.
Yes. Great. Mads, you'll just introduce yourself quickly.
Yes, I will. So perfect. And you see my slide now, perfect. I hope, as well?
Yes, that's perfect.
Perfect. All right. Yeah, and Peter, thanks for a really interesting presentation. And Leah, thanks for your hard work on keeping all these webinars flying. It's been tremendous to be part of it. So the overall purpose for our presentation today is threefold. We're trying to introduce the initial work we've been doing with the elements needed for data space from the KMD side and with some Danish customers. And then Arne Kovac, our colleague from NEC Heidelberg Research Lab, will present some of the examples of an initial data space between Japan and Europe. And then also the 5-year vision into this data space. As you could see from Peter's last slide here, there's a lot of stuff going on in different areas. So this is also a way of introducing you to the 5-year approach into data spaces. Me, myself, I'm from KMD. I'm the innovation director. So my job is mainly to look into the future of what technologies would be relevant for KMD and the different products we do and have and services, and what new products and services we might need to have, and then find a way to slowly play around and explore new technologies and implement them. And one of the big topics we have right now is data spaces. Yeah, I'm not going to give you the big who is KMD. Hopefully, most of you from the Danish background know KMD. And in 2019, we were acquired by NEC, a huge Japanese company, where having a lot of different research labs around the world. And one of them that we work closely with and are intensifying our collaboration with is in Heidelberg, and that's Arne presenting that. And I guess when we get to your part of the presentation, you can just put a few words on who you are and what you do. So let's do it like that. I think we just got a really good slide from the value proposition of having data spaces. This is just to give a framework of how we in KMD look into data spaces. We have a technology and innovation strategy with 5 overall trends, and one of them is data spaces. Just from sort of an inside-out perspective, we can see that being part of a software development IT ecosystem where we have multiple roles of consuming data, exposing data, exposing infrastructure, complying with different standards, that there's a big need for this data sharing alignment, European level exercise, or you could say, because there's a lot of potential that we are not tapping into right now, and there's a lot of work with that to be had. Yeah, and from not only having sort of the inside out, but there's also the outside in, and I think we was touched upon in the previous presentation in a really good way. But this general problem we have across the European Union of sharing and utilizing data across organizations, across countries, and even sometimes just more locally within large organizations. And our business is software, and our business is depending on a raw material of data. So the better data we can get, the easier it is, the better data we can expose to others, the better chance we have of going from data into knowledge and from knowledge into action. And some of the big problems we hope to solve with this kind of infrastructure is requiring a lot of new action. So that's also why we find this agenda extremely relevant, and specifically in the context of the energy sector as well, and the flexibility discussions that we have going on right now. And then, of course, beside the energy sector, there's a lot of different areas where data spaces become extremely relevant from these common European data spaces. And from a company like ours, we touch upon all of them. And I think some of the big problems we would like to solve will cross some of these data spaces. So not the intra, but the inter data space that Peter just mentioned is also a very interesting part. But we have started focusing a little bit more on the inter data space, the closer one from KMD side. I know Anu has had a bit more broader view on it. And just to circle back to this slide that hopefully some of you remember for the previous webinars, we're stepping into these data space enablers. And the focus we have had in KMD is the gray box in the bottom called context broker. And I'll go more into why we have started with the context broker, and then now looking more into the connector part together with Anu and his team. And unfolding a little bit that box of technical enablers, I think this is also a relatively well-used drawing of what technical building blocks are needed for a data space. And of course, there's many angles to where to start this work with it. From our point of view, we have started with the data interoperability because it's not only as a large data space scale solves a lot of problems, but it actually also solves a lot of problems just at a smaller scale on either company level. And if you do work with this kind of data interoperability on a smaller and more confined space, you can often also see your way out of the data sovereignty and the trust issues, because you might have that trust within your own organization to actually just work with the data models or work with how you exchange data in a good way. So for our point of view, that has been the easier way to get started and get a taste of it. And that also sort of relates a little bit to the missing interoperability as we see in many solution level, but also on organizational level and on national level as well. Even just from our core customers, the municipalities or state agencies in Denmark, we can see that there's a lot of data isolated. There's a lot of vendor lock-in going on, and it's not to say that we don't have legacy in that area as well. We do, but it's how can we then utilize that data from multiple systems and expand and scale projects and products and have that more complex work without it being depending on expensive data brokering mechanisms or integration projects. Our approach into solving this problem has been looking towards FiWare. FiWare is an open source ecosystem, sort of point of departure in the smart city world. We have worked, of course, with the NGSI LD Scorpio context broker created by NEC, and it's always nice to have good colleagues that create great software, because then you get closer to it, and it's easier to have all those questions you might have. But it works with standardized API. It's compliant with the NGSI LD standard, and also working with these standardized smart models. It solved some of the problems we could see in the first step of stepping into data spaces. If you haven't checked out FiWare, I would completely recommend doing so. As a lot of the other stuff, it's open source. It has a really big and growing community across Europe and across European cities. So quite an interesting data stack as well. So via that, we sort of set ourselves 3 steps into working with the data space future, and sort of starting with the smaller scope of it, even acknowledging that, you know, the large scope is where a lot of the value come into play, but we can still work with some of the elements on a smaller scale and prepare ourselves for working with that larger scale data space when the infrastructure is widely integrated. The context management with the Scorpio context broker was the first part of it. It works well with multiple sources of different data, and it works with these open source data models that we've been working with as well, and open source components. So it's relatively straightforward. It's not, but it's complex IT. But if you're a good architect, you can go for it. Then we work with sort of a lower level digital twins. I don't know if you remember one of the first slides that Leah had in the presentations in one of the previous webinars, saying, you know, databases is an infrastructure of how we share data. The end goal is kind of moving towards the digital twins and the AI, and how we can have a ground of really good data to work with these kind of technologies to solve these complex problems that we're facing right now. But before we have that big implementation of data spaces and access to all that wonderful data, we still need to practice how to work with digital twins on a lower level. So we started working with that in a EUDP project with a southern Danish university and an engineering company called Provi and a municipality in Denmark called Aarhus. And the idea is energy efficiency on building level, but you know, the digital twin idea can scale when we have more data. And then now moving into the data space, looking more into the ecosystems. And if we were to put that as a platform drawing, it could look like this. You have multiple data sources, as we all know. You need to sort of sort those data sources, understand where they are, how they relate to one another, and then not stepping too much into the minimal interruptible mechanisms, but they are quite interesting as well. It's MIM compliant with level 1 and 2, so the how to share data and the data models itself. And then we're working with open source visualization layers and the first infrastructure components for visualizing and working with digital twins as well. And as you can see, the dotted line is around the data space, because that's the next exploration that we're doing, is understanding how will this then connect into the data space, and how will you have a good step with having a context manager and working with context data into the data space with the interoperability mechanisms in that. And just because we talked about technical components, I thought I would just bring something that looks very technical, and it's the platform I just showed you. It's just a technical open source components beneath it. So you have the data coming in, and then you have the heart of these kind of platforms is context management, and we have the corporate context broker. You can see it's also where it gets sorted into the data models, and it's also where we can expose it via APIs. We then use open source visualization like Grafana, well known, probably most of you know it. The idea is to not play into sort of a closed licensed visualization layer from the beginning, because this also requires a lot of experimentation with how you would like your data to look like and how it relates. So it also, in my opinion, needs to be open for that without needing to have a lot of cost attached to it. And then we played around with creating an infrastructure that can grab different models or use different models, but not that much that we need to use to do the models. This is where the openness comes into it. These models is from the Southern Danish University, and they created these energy models. And I think that's the openness that these kind of problems requires, is that you don't have, you know, the old days of wall-to-wall carpet solutions. It needs to be open so you can adjust to the problems you have at hand in front of you. And yeah, I guess this looks a little bit like the drawing we just saw. But the idea here is that you have that data space connector, and that's what we're looking into now. And then you can have that data. When you get more data, you can work with it at your site, or you can expose the data you want others to work with in that. But I know that's the idea you've been playing around with. So this is where I elegantly hand the torch to you. Oh, you're muted. You're muted. We're doing a classical beginning here.
The classical beginning. Thank you.
Yeah, perfect.
And please operate the slides for me, because before we hand over the things, it's too difficult, even in our modern times. I have two tasks at hand. I want to introduce to you, and maybe the worldwide first project in which we connected a Japanese data space with a European data space. And to make it clear, these data spaces are operating on different technology grounds. So we had to have a look on the interoperability, but also on many of the different kind of interoperability, being on the legal side, on the administrative side, on the trust side. here. So that's the first part of my talk today. And the second part is an outlook on what we are up to after seeing what Mats has presented about the context management and how KMD is building up a smart city platform and a city platform that can also be used, for example, in the energy space. And what is happening there with the DSBA compliant 5-ware data space connector. So I'm going to be having a bit of an outlook what we are doing in that area and how that future will look like. With that, I'd like to jump in, and I know we are behind time, so I need to squeeze a bit. So I apologize if I speak fast and skip parts of the slides or complete slides here. Let's start with an example. If you look at what is happening with green products or decarbonization, one of the most important part is that you should be able to capture the complete carbon emission of a product. And that means they would be called green products if they can quantify the carbon emission and can explain that they are much below their competitors. And what is needed for that is what sometimes is called a digital product passport, where this digital product passport captured what was used in carbon, for example, in the production process. So you need to capture the carbon from the raw material over all the logistics and transport that is happening towards the intermediate steps of creating the product to the end product, and maybe then also to the usage at the customer side. And that's the challenge, and that is what is actually a very good motivating use case that is showing that you need to have international, global data spaces, or at least the ability to exchange data on the global scale. Because next slide, please. This is how this international supply chain will look like. You see, you have maybe in Europe, green is Europe and blue is Japan. In Europe, you have the raw materials, you have the initial production of components, you have maybe transport within Europe, and you get the raw material and the products into a first part manufacturing. And after that, these parts will be transported from Europe to Japan, and again put into factories. Parts will be produced, and then there will be the final product, which goes to sales and which goes to use. And to have a really complete view about the carbon utilization of that product, you need this digital product passport, which is capturing the data from the beginning to the end of the life of that product. And that basically needs a data space, and it needs a data space that is going from Europe to Japan. And that's what we started building roughly a year ago. Next slide, please. Why are data spaces, had been said before, they're going to be really relatively quick, but the use case, the supply chain use case already showed we need a decentralized data management, not a single cloud or single operator which handles all the data, many stakeholders involved, many parts producers involved. We need a common set of government mechanisms of the data. The trust need to be established, a common protocol stack to make sure that the data can be exchanged. And we need to follow the local legal systems and local policies and recommendations. So we need technologies. And in addition to that, the different regions of the world, they would like to have their own technology sovereignty. So it's not easy to say we define one European standard and then everybody's using it. There will be other regions of the world with their own standards. So we need to see how that is fitting together. Next slide, please. The overview of what we did is basically we looked at the carbon production of the systems. We looked especially in the logistic part, and we had a European data space which were getting GPS traces from the lorries which are transporting the good, which were collected in with the help of an open source component called Mobility Toolkit from the CFO project. We are connecting this data in the NGSI LD context broker. And that is then abstracted to an observation called emission observed. We do the same thing on the Japan side. Thought on that side, the calculation was less done on GPS, but more done on the consumed gas or energy, electrical energy, which is then also a one-to-one mapping into the emission that is generated by the respective cars and trucks. These two types of data are then integrated, and an external software house was able to collect the data across the supply chain, calculate the overall carbon emission, create the digital passport, and provide it back into the data space here. So that is the idea. That's what we implemented. Next slide, please. Basically, what we need now on the abstract level is that peering between two data spaces, meaning we have to have a connector A, we have to have an exchange adapter, and we have to have a connector B. And the exchange adapter is doing all the heavy lifting of what I explained to you. We need to do the adjustment of the protocols, of the legal aspects, of the trust frameworks here. And it's not an easy part of software, and it is something where sometimes you see how current defined standards are not allowing to do these kind of things. As an example, many of the trust components are basically saying we're only trusting ourselves or systems following our standard here. But if you now need to connect different technology-sovereign protocol stacks, you suddenly hit the wall that this is actually not allowed. So you either do something which is half legal or not really following the rules, or you really have to break the system, and suddenly you have actually an untrusted system, because at the exchange adapter level, you would send the data to the other side. So we have explored through that project that we need to have some extensions of today's standards, which would allow this kind of interoperability to be specified and then also to be enabled, so that an exchange adapter and the respective technology role can be implemented and defined. Next slide, please. Here is the roughly the flow of data. I'm not going too much in detail, but basically we're taking the raw information from Europe. We are publishing that in a common data format using the smart data models and 5R and announcing the availability. The exchange adapter can discover that availability, insert the discovery or the description information into the Japan data space where that can be looked up. And then the respective components like the aggregator, which is collecting all the CO2 traces, can access the data and get it together. And we showcase that in really a running data space for several months between the Europe side and the Japan side. Next slide. The resulting system, as said, is this connector with the exchange adapter in the middle, talking from the Japan charter system. That's the name which they have and which they're using as part of their DataX projects, and an IDSA-based system where 5R is running over an IDS or IDSA compliant connector here. Next. The issue solved, we looked at the trust part, still a bit of open, but we were able to, at least with a bit of trusting into the exchange adapter, ensure that both data spaces can talk to each other. We looked at the protocol conversion mechanisms on all levels, like the discovery, the data exchange, the subscription. We looked at the data model adaptation from one data model to the other, and we had a look into the legal interoperability of these systems here. Next. So that is the lesson learned, that a lot of these things can be solved with a lot of hacking and then putting effort in the middle. But we see that especially for the trust part and following the trust part for the legal part, there need to be additional agreements, additional regulations, most likely extensions to the standards being done, which would allow that data breaks out in a controlled way out of the data space on the one side and being utilized in the data space in the other side, and maybe with the support of a trusted component in the middle here. And that is things which are currently not being looked into in the standard and which we think we needed here. In the bullet point down there, we see that a single usage control policy is sufficient in one data space, but we have different usage control policies in different data spaces that need to be made compliant, and we need to have the specification, the respective standards. Next. So that was the project which we like to explain, where we really worked on connecting European and Japan data spaces. My next part for the last 2 minutes on the official timeline would be to have an outlook into how data space in the future would form, especially on the 5R-based data spaces. Next, please. So this is, we would like to look at how this connector vision would look like, and we concretely realized and how the vision could look like. I will skip a lot of slides now because of the timing to come slightly back into time. Next, please. So what is the idea? We would like to have this data space with a data space connector connecting the smart city to the traffic, to the smart port, to the smart logistic. We like to have a marketplace inside of that data space where data can be offered, where access conditions can be negotiated. And through that, we would like to have the data space for the energy sector or for the smart city sector here. And we would like to have data interoperability, because as you know, data interoperability is not handled by Gaia-X or some other standards. You need separate standards for that. We need to make sure that trust and sovereignty can be defined and utilized. And we would like to enable the value creation. Next. So that's the vision. You saw the building blocks, not going into detail here because they have been introduced many times already. Next. There is a specification for, or there's a group called Data Space Business Alliance, where BDVA, Fiverr, Gaia-X, and IDSA are working together. They are defining a minimum viable framework, how data spaces can work together. And as part of that, there is a data space connector being defined. The Fiverr data space connector is the first data space connector that is DSBA compliant. Next. From the technology building blocks, you see how we are handling the various parts as introduced. NGS-ILD from Fiverr as the exchange service for data. We are using the smart data models as the core elements for interoperability on the data model level. We are following the EU DID wallet architecture and APSI. We have a decentralized identity management, and our authorization framework is integrated. And through the value creation, we are supporting catalogs like DCAT version 3, some metadata brokering, and marketplace ideas, especially also using Teamform APIs. Please read the slides for more details. I was very fast here. Next. Basically, the data space connector is something that's released that you can start utilizing here with various of these systems. Next, please. This is how the data space connector will work, like very technical speaking. You see, you have the different participants, and we opened up the box of how it's looking like inside of the participant A. Next, please. Now you see the different components that the Fiverr DSBA compliant data space connector is implementing here. There's the so-called Kong gateway, which is an API gateway for intercepting all kinds of API calls. This is where the policies are enforced inside of the data space. The API gateway is then forwarding the API request to the Scorpio broker, where the real data exchange is happening, including all the powerful mechanisms of context management like query subscriptions, forwarding, and these kind of things. Here, the next, please. So you see how the data request is going through the gateway and to the broker. But at the gateway level, you're intercepting the call and you're trying to verify the data space requirements, like the policies being defined. That goes to the respective PDPs, so policy decision points, which is using a Fiverr-enabled verifier to make sure that we can talk to the trust authority, in this case, a Gaia-X compliant trust authority, which is then checking the verifiable credentials and sending the result back so that the Kong gateway can then let the data through, pass it through or not here. So that is something where authorization as well as usage control can be verified. So that's the architecture and the example, how that is looking like. Next. And the summary is, for us, we see really the data space idea as an European answer to the hyperscalers, where the hyperscaler is basically saying, give everything into my cloud. I'm exaggerating, but that's what is somehow the business model. With a new cloud model based on federated data processing, being able that everybody can be participating in this cloud of federation, that you are flexible. There's nothing wrong with having one big trusted source which do everything for you. But if you want to do it differently, we should be able to do it differently. And that's what data spaces, Gaia-X, and related standards, including Fiverr, is all about. Data space enable this trusted data sharing. They provide data, for example, for the future needs of AI training. And this webinar should show a bit how data spaces can be already realized. We gave an example for that and how it could look in the future. With that, I'm giving back to the organizer.
Thank you very much, Erno. And There are no questions in the chat. I'm sure there is a lot of questions because I have a lot of questions myself, but but we're getting a lot of, I think you all managed to draw the big picture. What is the vision with data spaces, and actually say what is there, what are we already working on, what you say you want to show that it's already there, we can already build it now. I think in between the big vision and what's happening now, there's a lot of questions on how to move forward. You all promised me to keep time for questions. You didn't, so we don't have time now, but I do keep some time in the end. So we'll quickly be going over to Jens Schwe from Energinet, and Energinet is the Danish TSO. We've heard from you in the second webinar from Jakob Faurskov, but Jens, you are much more into your technical development of working with data spaces. So please, the word is yours.
All right, let's see whether or not I can actually live up to that, but hopefully. So I am Jens Schwe. I am employed at Energinet as an information architect in our digitalization department. I won't go into what that means, but so I would have a slightly different angle than the previous speakers. I will talk a bit about how we use the data space initiative internally to mature the organization, so that we can, in the future, hopefully benefit from the data space. So I will not talk specifically about the data space itself, but some of the prerequisites necessary for the organizations. So yeah, I think the audience should be very familiar with this picture, at least some variations of it. So in essence, to me at least, the data space envisions that a data product can be shared between actors, participants in the data space who previously did not know each other, which is kind of unique. It consists of some soft and some hard infrastructure. Here in the picture, I would say it's mainly the harder infrastructure. So for instance, the identity provider and the vocabulary. Some of the things I feel like it's neglected when we talk about the data space is the data products themselves. If we are to scale the data space, I think we should start to address some of the products that are to be shared and what are the technical prerequisites to actually share those sources. So that's essentially what we're doing. So we're looking into some of the technical aspects that's necessary to make a data product clear for receiver of this product in the end. And also, I think we should start to address there are several types of products. We have a batch product like historical data, which can be shared as a dump. We have streaming data, and we have prediction data as well. And all of these data sources have slightly different prerequisites when it comes to technical aspects. Similarly, the data space needs to handle them significantly different. So what are we actually doing? So the data space has all of these technical building blocks. All of these building blocks have some kind of roadmap which need to be implemented. They are not big bang approaches. They have a lot of implementation phases along the way there. And that we looked upon and did a bit of analysis to make ourselves more attractive and become data space ready in sorts of manner, to mature internal aspects, essentially make data more clear, and then the interactions themselves upon sharing the data later on. So the question that we asked ourselves is, what are the technical foundation necessary to actually participate in the data space? What are the data products that we want to share, and how do we want to use it for operational purposes? So here I have a touch point upon some of the technical aspects. I would say it's close to the data models. So how can we use that internally? On the diagram here, we have the very famous data information knowledge wisdom pyramid, which in its essence, addresses certain levels of maturity when how clear data is. At the lower level, it's quite unclear, and on the very high level, you can actually apply knowledge and extract wisdom and use it for operations. We looked upon this pyramid internally and say, why are we at this moment? And then we asked the question, what are the prerequisites to actually, well, participate in the data space, and how do we want to use it for operations? So one of the questions that I would like to ask the audience as well, and please, I would like something in the chat here actually. What would you expect from a data product from the data space in order to use it? And I will give you a few seconds. Obviously, I have some answers myself, what we found. So we found quite a few things. I have some of the examples here. We believe that, well, data should have a clear meaning. It should be very understandable. It should be semantically unambiguous, and it should be documented using data standards, ideally international data standards, so we can actually understand what they are and what the data represents. Obviously, that maps to this pyramid. Then we also would like, as a receiver or data user, that the processes that the data has gone through is documented, such that as a receiver, we would know which kind of optimizations, normalization, and such happen to the data along the way. We'd also like a documentation upon how the data was collected, what kind of sampling scheme was used, and also we would like to have an answer how reliable the data is. What kind of data quality is there? What kind of how can we use it for operations? And well, quite a few things more. I have an example here. You can read that afterwards. How you can make data more clear and understand what it actually means. So one of the questions that we asked to kind of get into some of these initial questions was, how do I know as a data receiver or data user which kind of data product I'm actually starting with, and how can we then use it later on in operational aspects? Some of these answers, this is a very similar question to what has been asked in the open data community. I think we need to take it slightly further in the data space, because we can actually document it. We have the technology to do it. But let's see. So here, for instance, I have let's call it a toy example upon a data collection scheme and a data space. So we have a power meter collecting data. We have some kind of processing unit. Let's say it's normalization. We have a data store, which stores the data, and we have a data space connector sharing the data among two data user, which then processes. If the data user is to have a clear meaning upon what the data actually is, I think we need to document how the data was collected, like the sampling scheme, the normalization scheme, the downsampling scheme, and such that when the data later on is used, I can see the flaws potentially, and I would know which product I stand with. Clearly, when we come to operational purposes, I would need to understand that in order to act upon that data later on. So, for instance, can I use this data with the risk of losing money, or can I use this data for, well, risking harming a human? Based upon all this knowledge on this sampling scheme and the normalization here, and which kind of process this entire thing happened in the first place, then I can take a decision as an organization, how can I use this data? This is essentially lineage. It goes slightly beyond what the data space initially was designed to do. The lineage and provenance and traceability is documented in here, but I think we should start addressing that there is a prerequisite from that lineage, which goes to the host organization collecting the data, because there's a lot of things happening towards the data prior to it being stored to some kind of data store or into a stream. And that should be documented such that the receiving organization would know what happened to it and then can take decisions whether or not they can trust it and act upon it. We also asked, how can I use this data in operations? It's slightly connected to what I just addressed. And which kind of governance structure was surrounding it. So back to the same picture. I think we also should start to talk about the digital trust needed in order to, well, rely upon the data. How trustworthy is it? So the data space itself would obviously handle this kind of trust. So we can trust the organizations sharing the data or the legal entities. But can I actually trust that this organization handle the data responsibly? And what kind of transparency do I need for that? And then I think we should then start to talk about, do we need trust upon this normalization process? Do I need to be transparent? And do I need some kind of PKI signature stating that I did this handling and no one can manipulate it from this point out? Otherwise, we would at least know. Similarly, we might also need trust all the way down to the sensor, such that the sensor signs, I collected this data, I'm responsible for it. If something happened to it from this point out, we would be able to see it. This is slightly different in the supply chain. What we do currently is we do closed networks, sharing the data, and data doesn't leave out the premise until we're done with it. In the data space, if we are to use it for operational purposes, we would need this level of trust all the way down to the sensor, such that we would know as a receiving port, this data is collected from this sensor, we can trace it, and nothing happened to it along the way. And then we can start to create mitigation strategies if something happened to it. Well, I presented this as either or. In reality, it's not. It's an and. We need all of it in order to have the transparency of what happened to our data along the way prior to it coming into the data space and being shared. That was actually it. I don't have further.
Great. Thank you. We don't have any questions right now, but Arno has posted an answer to your question. What do we need? Reliable use and long-term availability. But I think, Jens, what you showed is because what we have is the big visions out here. What is the full data space? What do we actually want to do when we have it? Then there's a lot of work to be done in Eclipse Data Space Foundations, with KMD, with everyone, but there's also a lot of companies sitting out there saying, we have data, we want to use data, how can we get started? A lot of people are kind of, want to get going, but what can we actually do? And I think what you're showing is a lot of what we can do is to actually make sure that the bricks are laid right at home in our organization to be ready to share data, to understand what does it actually mean, what is the requirements from our data when the infrastructure is ready to go. So to say, to pack the bag right for the journey. So thank you very much for that, and I hope that it can inspire some of the other companies that I know was joining today who has data and want to receive data in new ways in the future. So Mads, you have one question?
If we have time for it now.
We can do a quick question, yeah.
Yeah, because yes, I recognize a little bit the same process we've been through with the whole idea of approaching the data models and turning up the quality of the data you have and how that works. You see it in the perspective of preparing for data space, but has it also qualified your internal work with data? And how can you see that in your internal processes? Have you gone further up the wisdom ladder you showed us with some decisions? On a practical level, how has that been shown in your organization?
In reality, it's a long journey. I think it will take time. Let's be honest. and some of it requires reinvestments in new equipment, which is significantly costly. So, well, we haven't seen the benefit from this point out. We will, let's be honest, we're drawing the lines to figure out what to do about it. We haven't really gained a lot of the benefits from this point. I just want to point out that we should remember the data space is a great idea, but it doesn't become better than the data products that we share. If the data products aren't clear, the data space doesn't help us.
Right. You're right.
That's a good point.
Good. We'll have to jump on to our next speaker. So Sebastian Klaff, you're the CFO of Sovety, and you have been actually trying to put, or you've been putting some of these components into actual implementation and made them work in several data spaces. So please, the floor is yours.
Thank you. Good morning, everybody, and thank you for having the chance explaining a bit on what we as Sovety doing, because we have seen a lot of initiatives, consortia want to establish data spaces, however, see a lot of complexity as well doing so. And this is what we have as our vision to make data space technology available for every company. So who are we? We are quite a young company, so founded in 2021 as a Fraunhofer spin-off. However, we are involved in data space topics via Fraunhofer, via also other initiatives. I personally was employee number 3 of the international data spaces back in 2016 when it was originated. So we have a quite strong background and experience knowing the turf of the technology, but also the different use cases quite well. We are involved in several data space initiatives. So, for example, Catena-X is went live 2 weeks ago or last week. Time flies. Where basically now it's the next operational data space. However, we're also supporting Omega X of energy sector, but as well as mobility data space. And we taking open source technologies, which could be, for example, the Eclipse data space components Peter introduced in the first slot today. We're taking this and making a product out of it. So really to enable that, we are making it possible for companies to join in data spaces. So I think what data spaces are, or what is all about, I can briefly go over it because we had already quite good and insightful talks this morning. So why or in what kind of use cases do we see data spaces relevant? And I've brought one example here, which is the CO2 footprint. By law, car manufacturers now from next year on need to document and communicate the CO2 footprint of the production of a car. And this comes with 2 typical requirements. On the one hand, a car consists of thousands of parties, and an OEM like Volkswagen, they have thousands of suppliers, which means collecting data from thousands of sources. On the other hand, also the suppliers don't just want to share the data without having regulations or basically just providing sensitive information via email. And that's why I'm talking about sensitive information. And those 2 components are like the scalable approach and the sensitivity of information are 2 typical requirements where data spaces are relevant. And those problems or those requirements are covered by data spaces. So a standardized approach to communicate with thousands of parties in the same communication protocol, but also decentralized and data sovereign. That means that the data remains with me as a data owner, and I can define for what purposes, for how long, or with whom I'm sharing the data. And maybe also interesting about Sovety. So we are not funded by any research projects. We have a commercial interest. We are founded by venture capital funds. I think this is also interesting to highlight that we have a key motivation to drive also industry towards data spaces. We want to make our products available to the industry and companies. So to really make all the different data spaces happen and accelerate them. And here we see that very many different data space initiatives are established, and all they build their own use cases. So for example, automotive, I explained the CO2 footprint, but also energy, talking about a smart grid, and mobility, where e-charging plays key roles. However, we see basically in all the different domains that there are initiatives established and companies forming consortia to share data via data space. This or a similar picture Jens has shown already in the previous slot. So how is what is the technical architecture? So we have, of course, data provider and the consumer, but also Peter mentioned, I think, a key component of a data space is the authority. The authority defines what are the rules, how can I participate, but also from a technical perspective, how decentralized or how centralized am I going to build my data space? What we also see as a key role is the data space operator. Usually the authority is not a cloud provider or a technical company. We see that they collaborate strongly also with data space operating companies, who then ensure that the data space runs and participants can share data in this data space. And talking now about, so these were the roles, and talking now about the different components. So we have heard already about the connector, which is the single gateway to the data space as a data provider or consumer. So I can share or consume data via a standardized interface within the data space via a connector. But then also quite linked to the connector is the data catalog. So basically I want to browse data and see what data is available in this data space. And then we have different other, so there are different namings, also shared services, core services, or federated services, which are part of a data space. For example, in Catena-X, the digital twin registry plays a key role to store also the digital twins of products available, making this available for a data space. We have an authority portal in place, for example, in mobility data space, where the authority of the data space can do their management of the data space, see who is involved, what components are running, what data is floating, logging of metadata, but of course not logging the actual data. And also the identity provider in the middle, a central role, which ensures that the different parties across the other company is basically trustworthy and ensures the authentication between the parties. And also within this identity provider, I think we see different variations of the technical realization. Some have more like a centralized approach coming from the DApps from IDSA, so the central identity provider, but also Catena-X, for example, now is moving into a more decentralized approach, talking about SSI, self-sovereign identity, which makes it even more federated. I've shown just put basically the two logos where we also have a strong involvement and knowing the entire data space quite well, showing that some of those components, so for example, connector is used by mobility data space and Catena-X. The data catalog has a stronger relevance in mobility data space, but some of them are shared, so basically used by all or other data spaces, but some of them are also very relevant. And this is defined by the authority. So this is where basically the technical definition of how a data space should be established is defined by the authority. So this is the technical setup, but what are obstacles? Why are not data spaces all around? So also, this was one of the key motivations for us as Soveti to build a product around it. We see that this is super technical, and I hope I've tried to not make it too much into architecture and technical descriptions. This is still technical, and especially industrial companies usually don't have the IT capacities, not maybe the skills, and also setting up an infrastructure for a data space is not core of an industrial company. Industrial company should do manufacturing, should produce industrial goods, cars or energy and whatever. And this is where we see this is more like foundation, should be commodity for everybody to have access to a data space. And this is exactly what we have taken as our vision. So we provide software products around data sovereignty. We call data sovereignty as a service. So software as a service products, which we can distinguish in two areas. On the one hand, the connector as a service, which allows data space participants or interested parties to get onboarded and to join an existing data space. So I, as an utility company, now want to share data with my data space Omega X, and now I can use a connector as a service to participate in this data space. The right-hand side, data space as a service, is more like for data space authorities. So I, as Catena X, would like to set up the entire data space. So I want to have an identity provider. I want to have a data catalog and an authority portal. And all of these different software components are then leveraged by us. And why do we do this? We don't want to start from scratch every new project, every new consortium. We have seen also research projects, first 8 months, mainly focusing around, what do we do? How do we set up the data space? This is 8 months, which is not worth to spend anymore. This was now done almost 10 years. And there is a stable version of a data space which can be just leveraged. And the 8 months can be very well used to share the data, build use cases on top of it, or prepare your internal data to make them ready for sharing. And this is also our value proposition. So with our products, we enable that companies can start immediately participating in a data space, can focus on the value creation, can speed up the use cases, and fully based on existing standards. So we are using IDS, Gaia X, we have a Catena X certified solution in place. So we are basically based on the different standards and open source components which are in the market and building a product out of it. As Peter mentioned at the beginning, what Eclipse Foundation is doing is not providing a product to companies, it's a framework of components and modules. But this framework needs to be brought together to a product or as a product to be usable. And this is exactly what we're doing. So I've shown, brought here a capability map of what we're covering here. You see in the middle, the open source core, how we call it. So different software components from open source repositories are the core part of our product, ensuring keeping the standards, ensuring the standardized communication, but we're building a lot of functionality around it to really make it usable, being it a front end, being it integration of use cases so that you can not just forward it to a data sync, you can also integrate it with your dashboard, with your applications, or on the other side, the company data sources, thousands of different communication protocols, authentication methods, or actual databases are around, and this needs to be integrated. This is where we are building tooling around it. We don't want to do data integration consulting. We basically focusing on a product. So I know we're a bit behind the time. I also wanted to quickly show a demo. Maybe what I would show in a second is basically our connector, which is based on EBC. And this is how is this product used? So we can connect. So we can connect the data sources of a company to the connector and integrate it to it, and then basically share a data offering, or how it's called, a contract, to the ecosystem. And then another connector can view the meta information, what are the policies, what is my technical contract, and then consume it. And this is still a technical view, which you will see in a second. However, this is really the foundation based on open source technology, which is coming from IDS and other open source and standardized documentation. So I hope we still have 2 more minutes. I try to wrap it up quite quickly.
You have a couple of minutes, Sebastian. You've kept the time, so
perfect. So now you should see a web browser, and this is also the starting point for our customers. So our customers do not need to deploy something in the infrastructure. It's a web-based solution based on EDC. So you see EDC connector, some descriptions here, and this is basically the starting point, getting an email with an URL with login credentials, and then you can start the journey and you can just use the connector and share data. This is the dashboard where you see some explanations, some connector properties. So to what dApps are we connected? This is the identity provider, but also some dashboard information like how many data assets or data sources are connected to my connector, and how many agreements, so how many parties are consuming from my connector. How this process usually works. So in the first step, I connect assets. So I'm creating an asset. The asset is now any database or data set which I want to share within the data space. So I'm just to show you what is happening, I can now define, this is the meta information, which also the other participant will see. This is the test asset. Which I can just connect to my connector. I describe it. I can put keywords to it so that it's easily searchable. This is some key information here, just the meta information, and then I'm connecting the actual asset, which at the moment can be via a REST API, or I can upload a JSON file. So meaning that I now connect an available API to the connector, so the data remains with the data source, and just via the API it can be called when it's requested by other participants. We have some technical details here. For example, authentication, of course, is critical to have for example, OAuth 2.0 as a security mechanism to ensure that the data source is still protected. So this is, I'm connecting then a data asset, and we see that we have a couple of data assets already connected, for example, a mobility solution. And then we define a policy. So today, two different types of policies are implemented here. So one is the time period restricted. I can define now for just 1 week, this data asset will be available, or connector restricted, meaning just this one party or these 10 parties are allowed to consume my data offering. And the combination of an asset and a policy is then defined defined in a contract. And these are the contracts which are now visible for the data space. So, and now I'm from this day, so I have two connectors open here. This is, you just see they're looking quite similar in the URL. So this is the A. Basically now I'm switching over to connector B. So you see this one has no assets connected because this is now my consuming connector. And with the consumer, I'm going into the catalog browser. I type in now the connector endpoint, which is the URL from the other connector. And now I'm fetching the data catalog, so the offerings from the other connector. And I see, for example, this mobility solutions contract, which I've shown previously from the connector A. And you see that here are now the meta information, a description, a short description here, but also which version, who is the originator, but also what are the policies to be used. And now I want to consume this data offering. And here I go, because I've negotiated this contract already. So I agreed on the conditions, and I can find exactly this here. And now I want to initiate the transfer. What does transfer mean? That the data is going via the EDC to a data source, which can be an application, can be a data sink, can be the connector itself. And as we in the demo here, we want to use now a webhook site, which is just a web page where the data can be put into a data sink so we can see something. And this is what I initiate now. So it's a REST endpoint where I put this URL from the webhook site and I initiate the transfer. And now what is happening in the background is that the data is fetched. And now we see that it's already completed, and we should, yes, exactly. So now this is the data sink, is that now the data, that's a JSON file, it's showing here a mobility service from BERT, and maybe some of you know the the e-scooters. So we know now it's a public available open API, the locations of specific e-scooters in a specific city. So this is the information which now was transferred between the two parties. So that was in a nutshell quite jumping over it. I can quickly summarize 2 or 3 more sentences. So basically, what we provide is easiest access to data space technology, so that every company can use data space tech, can build own data spaces, but also to just participate in a data space. And we continuously further develop this technology and make it available so that we lower the entry barriers to data spaces. And happy to answer further questions now. Thank you.
Thank you very much. There's a comment in the chat, but no questions. So I want to just ask if there are any questions out there. Mads?
I could ask a question. Yeah, thanks for a really cool presentation. It looks really, really interesting. When you in the demo, when you have these assets that you put into your data space, I guess that's that's connecting to the data sets you would like to put into your data space. How much work do you put into that? Because I guess also knowing some of the organizations sitting here, we have multiple varieties of legacy systems and odd data sources that might be interesting to put into this. How much work is it for you to do that integration? Or do you have a sort of a request demand thing? How do you do that?
So there is no clear answer, because it highly depends on the data maturity of the individual company. So do they have REST APIs available? Then it's just a matter of seconds. This is the easiest step. However, what we see is we support them also in defining and providing the right APIs. This is more like then in a couple of architecture workshops. However, the API also needs to be then somehow implemented by the company. Today, what we are working on as product features is, on the one hand, a data ETL tool, so extract, transform, load capabilities within our product, that we also can transform the data to maybe a target data format. This is one area, but also a capability to plug and play your API, so we are dependent on technical people in the company. What we do not do as much is really identifying the right data and preparing the right data, finding the right data within the legacy systems.
Okay, interesting. Thanks.
Very interesting. I also have a question for you, Sebastian. So that means, because a lot of us, if you're not part of a big EU project that is over the next 5 years going to build and test, and that, as you say, it takes a lot of time, but the rest of us who are just sitting out here in little Denmark and want to try to get started, does that mean we can say, we want to build up a small use case, 5, 6 partners, we want to just make a small data space to play around with this, that we can actually come to you and say,
yes,
can you help us build this as a service? Yeah.
Yes, definitely. So this is exactly, so it doesn't mean that because I have the logos of Catena here also that it must be a huge consortium. It's really, if you have 3 parties, 5 parties, companies who have their own use case, we can immediately or in a couple of days provide you the relevant technology, and you can start sharing the data and build your use case on top of it. And it also comes with low prices. Of course, depends on the requirements. What components do you need? But we're talking, so we have also around 50 euro is the starting point per month, but it highly depends on what you need.
Okay, that's interesting. I think that's very needed for us who want to start playing with it. Are there any questions out from the audience? Not so far. Then I think I would like to throw the ball back to Peter and maybe also NEC, because something that, Peter, you already mentioned the big elephant in the room. So now we move out to the bigger vision. You can see what is happening in EU right now is very much trying to make an alternative to the hyperscalers, but you are, Peter, representing one of those. I'm just wondering, how do we, in this development of this technology, ensure that this does not end up being another hyperscaler project. I think that the question has been posed in many different audiences, but I think now when we have you here, we have NEC, you're not a small player at all. You're not a hyperscaler, but you also represent organization that has been doing a lot of work also with close standards and stuff. I'm just curious about this.
I don't see data spaces at all as something that is against the hyperscalers. I see this as a much needed fundamental technology, as important as the World Wide Web to the world, to find a way to have trusted data sharing. I mean, there's never going to be 100% guaranteed mechanism of data cannot be misused, because there are attackers in every system. Every network has to assume breach. But data spaces help us building an infrastructure where I can make a risk-based decision of, do I want to share my data with the other party or not? The same way as when I go on business travel and I meet somebody in their office, I'm basically entering their data space based on attributes. Oh, I'm in the KMD building, so I'm probably in a trusted space. Oh, I'm talking to Matt, who I met before in email and online, so I probably will trust him sharing certain business information. But those are not guarantees. Those are risk-based decisions between two humans. And we need to get to the same point on a machine-to-machine level, so that machines can make real-time risk-based decisions on, can the data transfer or the data sharing be trusted? And because without that, we will not be able to have an innovative data economy. So this is not at all about sharing data with a hyperscaler or not. This is about, do we have something as meritocratic and democratic as the World Wide Web that shared information for humans to now share information on a machine-to-machine basis? And look, I absolutely do not expect that any of the hyperscalers will dominate in any of the data space discussion, because this is a technology that is being developed vendor neutral. It can run on your local laptop. It can run on Linux. It can run on Windows. It can be developed with Java, with C#, with whatever your fancy as development language. It is ultimately about the goal of multi-cloud, that it doesn't matter on what infrastructure, which provider works. It's about, how can I express to you my attributes, my claims that I'm making to be trustworthy, and how can you validate them before you decide data? So it's basically an acceleration of what we as humans have been doing for centuries already, now just bringing it to a level where it can happen at the speed of machines.
Great. Oh, I know you need to unmute.
Oh, I'm always doing the same error. Sorry for that. And as said, it's about having choices, and it's about not getting locked into systems. Hyperscaler as a business model is actually fantastic, not only for the hyperscaler but for everybody else, because it really got the prices down to a level that is quite amazing, and also the speed of getting things accessed here. But if that is leading then to this typical lock-in, if that's leading to discussion, no, let's go here, no, let's go here, I'm more familiar of that, then we have issues here. If it's limiting business market entries for people, then it's an issue. And that, I think, is what data spaces is about, that multiple party can get into the system, can provide the data, can provide a service, and that it can be easily combined here. And if we achieve that, then the data spaces have lived up to their promise here. And if then people are using it, and if people find other ways or good ways of creating value, of reducing cost for everybody, be my guest, that's what we're needing.
Right. Thank you. Jens, do you have a comment, or you just turned on your camera? I thought maybe.
So I think, again, we need to address the elephant in the room. The data space isn't better than the products being shared. Obviously, we can create the infrastructure around it so we can share things seamlessly, trustworthy, and with transparency. But again, there is a clear prerequisite, the data itself. If the data isn't clear, we can't use it for anything.
So thank you, Jens, for mentioning that once again. I already made a comment on that in the chat, but it's easier to talk about it than write about it.
Yeah.
It's one thing that we see all the time in data space discussions with customers and partners. There is this interest of saying, oh, I need usage policies. I need to be able to prohibit this, to enforce that. And then you go down all the way to the IT department and you realize, oh, we actually don't have that information about the data. We don't know if it's classified as confidential, if it's regulated data or not. We just scramble when the regulator picks up the phone and asks us a question. So what we see working very well in the first use cases is if there's a clear regulatory need to share data, because then they know what data they have to get from what corner of the company, create a dedicated data product that has a dedicated data endpoint, and that one is clear how to be shared. If you're going into the direction of, hey, let's create new business through data, most companies don't know what data they actually have, how that data should be structured to be resellable, how the data needs to be structured to be valuable to somebody else, how the data needs to be classified, how the data needs to be cleaned, how that data needs to be managed so that you can actually do discrete packages that you can share with somebody else. So I'd say today, when I look at data spaces, 10% of the project work is the data space infrastructure, 90% of the project work is the underlying data estate of the company and their understanding of their own data.
I agree. I just want to emphasize here again, on top of it, I think we need to address the A bug and not the R bug.
What is that? Even though we've reached time, but we can't end on that note.
We need attribute policies, not entire dataset policies, such that we can differentiate among participants what data can be seen from a single dataset, so we don't have to create multiple.
And to echo that, in most companies, you have role-based data management. You have a data officer who owns all databases and graciously provides them to the business. When you come to the area of data spaces, you need to be able to say, because of the attribute that you are a German company in the automotive business working on financial data, you will be allowed to see this subset of data and maybe this column only in an aggregate format over the last 7 days, because you're not allowed to see individual transactions. And this is the information that hardly anybody in the world has about their data estate. This understanding from how do I get from the internal role of a chief data officer or of a database admin to the external view of what claims need to be verified for me to share data with you. That is the real big part of work. The technical part of having a compatible protocol and open source projects that are able to interop, that's actually the easy part.
But to me, that sounds like there's a lot of work needs to be done on the data literacy. So both understanding what is the data we have, how can we describe it, how can we actually make it workable, but also I think we have a big challenge in 10 years from now, everything will be exchanged in data spaces, but even imagining what part of my data can be used for what, just I think is still going to take some work for the poor people sitting out in different holding or being responsible for the data to actually be able to describe that and make that meaningful for themselves and for others. But yeah.
So the good news is you've basically just participated in a data space, just not with data space infrastructure. But here's a group of people that joined a webinar and presenters that made decision on what slides to share, what slides not to share, what information to put into those slides. You made a decision of who will be invited as a participant just based on the attribute of those people. You didn't invite me because my role has a specific role title, because somebody told you, hey, here's this guy that has the following attributes, therefore could be an interesting speaker for you. So we humans are practicing data spaces already all the time. Now it's just a question of getting it codified and get our machines to do it.
Yeah. and make it easier to, for example, when I choose to invite you, I also make a meeting beforehand. I make sure that actually you can say something that will be meaningful in this webinar. And we've had discussions on what to talk about and the whole curating the dialogue. I think it's a good metaphor to use for how do we make sense out of data, because people make some kind of sense on their own. A lot of data does not. So I think on that note, I think we have to end this conversation here, but I know that it's not the end of the conversations. I want to thank you all for participating, and of course I will send you the slides and the link to the recording. Yeah, have a good day out there in the rain, here at least in Denmark. Thank you.